Hello and welcome to Home Science Lessons with Mr. Mac. Lesson 4, Investigating Potential Difference and Current in a Lamp, Resistor and Diode. So as we get started, make sure you got a pen and paper, that you switch off your phone or put distractions to the side and you have a go at this lesson to the best of your ability. Okay, so the lesson's going to take the same structure as always, starting with some retrieval, then some teacher instruction from me. In fact, in this lesson, there's 2 different examples of teacher instruction. And after each example of teacher instruction, we'll embed some of the knowledge and drill. And then you'll have an example to practice. Okay, slide 1 of the retrieval practice. Pause the video if you wish and have a go with your pen and paper, and I'll reveal the answers in a few seconds. Okay, here are the answers to that slide, all about structures and bonding, one structure of the atom. Okay, next slide is going to be some revision of particles and particle theory. So again, have a go. You don't feel you have to write out the whole table. You can just write solid and then list the things, liquid, gas, and list the different properties you're asked for. Pause and have a go. Okay, and here are the answers for that task. Okay, third and final slide is looking back to last lesson, and that was explaining the relationship between resistance and length of a wire. So if you could have a go at sketching the model, try and do it from memory, and what should be drawn in each box. There's a little guide for you. So box 1, model what current looks like in a wire. Box 2, model a short wire, and box 3, explain the resistance in a short wire. Box 4, model a longer wire, and in box 5, explain resistance in a longer wire, how it's different to a shorter wire. Right, pause, have a go. And there's your answers. If over any of those 3 slides that you got some answers wrong, please go back, write in your corrections, and do some more revision on those particular areas. Okay, so our first piece of new knowledge today is going to be on some definitions on what an ohmic conductor is. Okay, first of all, what is a conductor? A conductor is a material that allows a flow of charge. So a material that allows a flow of charge. What is an ohmic conductor? That will certainly be a new one for you. This is a conductor that has a constant resistance at a constant temperature. And 2 examples of ohmic resistors or ohmic conductors would be a wire or a resistor. Okay, so pause if you need to, make a note, because that's some new knowledge for you. And remember to embed the new knowledge. So drill is thrill. So how do we go about doing drill? Well, it might be that we look, cover, write, check. So cover up the information after reading it, and then write on a blank piece of paper what we can remember about conductors and ohmic conductors. Or we could get someone to test us on this knowledge at home if there's someone available. Okay, so we're actually today investigating voltage and current, or potential difference in current, for these different devices, such as a resistor, a lamp, and a diode. So what you're looking at there, that's the circuit that you would set up using an ammeter and a voltmeter to measure current and voltage, and then we would divide voltage by current to find the resistance. We could do that. And here's a set of typical results that we might get for that experiment if we increase the potential difference. So as we increase the potential difference or voltage, the current increases also. What about the other devices? Again, we've got the symbol for a bulb. We've got exactly the same circuit. In the classroom, we may have a variable resistor being used in this case as well, so that we can vary the potential difference that way. And there's our third circuit, and we've got a diode plugged into the circuit, which is our third device that we're looking at today. So for each one of those circuits, as we increase the potential difference, what happens to current? And that brings us nicely onto our next piece of new knowledge. In fact, there are a couple of pieces of new knowledge that we're now going to model under the camera. Okay, here we are. So what is the shape for a current voltage graph for an ohmic conductor? Remember, we learned earlier that an ohmic conductor has a constant resistance at a constant temperature. So how could we say it in words, and how could we represent it on a graph? Okay. So representing it as a graph would look a bit like this. We've got current on the y-axis, we've got voltage on the x-axis, and a typical set of results. As the voltage is increased, the current also increases. Now, how would we describe that and go about writing it? We would do that in the following way. As voltage increases, so does the current. The relationship is directly proportional. Double the voltage equals double the current. Okay, so there's our first piece of information there. Our second piece of information is about the filament lamp, and I've put a little extra comment here. It's a non-ohmic conductor, so resistance changes as temperature changes. So first of all, what would the graph look like? Well, if we plot the graph, again, voltage and current, the graph goes up to start with like a resistor, and then it starts to curve at a particular point. Now, how would we go about describing that? As voltage increases, so does the current. But the relationship is not directly proportional. As voltage increases, the increase in current is less than expected. And we can see it curving off here on the graph. And there's another nice little way to actually remember it. When you sketch the graph, so it goes up and then levels off, we can actually make that look like a little street light, a little lamp. And that can help us remember the shape of that particular graph. Now, what about the third device? The diode. So with a diode, we've got our voltage and current graph. At lower voltages, no current is able to flow, then suddenly current increases at higher voltages. So how do we go about describing this one then? As voltage increases, no current is produced until at higher voltages there is a large increase in current. And again, like above, there is a little memory cue which can help you. So if we sketch the voltage current graph, so it goes along and then goes up, we can actually change that first bit into a D, which spells out D for diode. So again, there's another little memory cue. So pause the video if necessary and spend some time writing your notes and then do a bit of embedding. But we'll come back to the embedding shortly. Now there's one other thing that we need to model and explain under the camera. And it's explaining why this graph curves and is not directly proportional. So some of these models you will have seen before in previous lessons. So I'm not going to set out what all the symbols mean again, but I will explain as I go along. So a flow map explaining voltage and current graph for a lamp. So this particular shape we've just been talking about. So this is how it would go. Here's our wire, first of all, right? So that's our wire that is inside the bulb. So we've got our circles here, which represent metal ions. So metals are made from positive ions surrounded by delocalized electrons. Now, if you find that I'm going a little bit fast for you to keep up, then, please pause the video and do this at your own speed. So those little dots there in between the ions, those are our delocalized electrons. Okay, moving on to our next box on the flow map. We connect this wire up into a circuit. So we've got our metal ions again. Doesn't really matter how many you draw, as long as you represent the pluses. And also that you show that these little dots, these electrons, are actually moving in between them. And that's our flow of charge or our current. And if we connect this up into a circuit, so we've got a battery or a power pack or something like that. So there's our symbol for a cell, and we're going to just say that's at 2 volts. Potential difference causes electrons to flow. This is current. So these electrons are moving through the wire because they're being pushed by that potential difference. Now, what happens if we increase that potential difference? Well, if we increase the potential difference, we're increasing the push on those electrons. So again, I'm drawing the wire. I'm drawing the fact that it's in a circuit. And this time we're going to say that that's 12 volts. So more PD, which stands for potential difference, causes more current. So these little electrons are flowing through. And they're flowing through at a greater rate because we've increased the push on them. So more voltage equals more current. So what would that do to a bulb if we increased? Now here's my little drawing of a bulb. What would happen in the bulb? And we've got it's an old-fashioned filament bulb, so we've got the wire there. What would happen to it if we increase the voltage? At higher voltages, the bulb gets brighter and hotter. So we can see the light coming out there, and that would actually get quite hot. So how would we draw this happening within the wire? Well, we've got our metal ions as before. And now I've put little commas around them just to show that they're more excited and they're moving more. And we've still got our electrons trying to get through. They're trying to move through that wire. And it's still connected up to the circuit with our 12 volts. So when the wire in the bulb gets hot, metal ions vibrate more and slow down the flow of electrons, increasing resistance. Because remember, anything that slows down the flow of electrons will increase the resistance and make it harder for them to flow through. So that very last bit, which is our graph, voltage, current, we use I for current, and it levels off. And this bit here, at higher voltage, the increase in current is less than expected. And we know that this is due to the wire getting hot and an increase in the resistance, meaning that it's harder for current to flow. So hopefully that made sense for you. And that's our new knowledge, explaining the shape of a graph in a resistor, lamp and diode, the shape of a current voltage graph. And then that other flow map was explaining the current voltage or voltage current graph for a lamp and why it changes shape. So again, there's quite a lot of information there. So you might want to take a good 15 minutes drilling on that. So read through it carefully, the new information that you've been given, cover it up, and then on a blank piece of paper, write as much of it as you can write. Or even better, if there's someone around, get someone to test you on it. Remember, drill, 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 drill is thrill. And if you can memorize this information, it will really help. Okay, that's the video part for you. And the teacher modeling, there is a slop task attached to show my homework, so you can practice on some of the new knowledge that you've just learned. So you'll be able to access that through show my homework beside the link for this video. And I advise that you go away, spend a good 15-20 minutes after you've drilled on the information and sit down and try and answer those questions. Thank you so much for working hard with us and taking these ideas on board. So next lesson is going to be on series and parallel circuits. In the meantime, do some retrieval practice on all that new information you've learned today. There will be a recall test on Friday, more than likely. Look out for it on Show My Homework. Complete the slot task as we've talked about, and tell your friends and buddies where they can find these videos to help them with their science lessons. Okay, thank you very much for listening. Thank you very much for working hard and for giving it your best shot. Thanks. See you soon. Goodbye.